Whenever you are creating multiple objects, it's important to remember that every property that you define on every object that you create consumes memory. Now, I know that that sounds rather obvious, but there's one thing that we tend to overlook, and it's just primarily because JavaScript is different from other object oriented programming languages. And that is that JavaScript does not have methods. We have properties that refer to functions. And in JavaScript, a function is an object. So anytime that you write a function in your code, you are essentially creating a function object that is going to consume memory. So just as an example, I wrote a function called person factory. This is an object that's going to consume memory so that anytime that we wanted to execute this function, we could by using its name and executing it by passing in the first name and last name values. As its name implies, this is a factory function, so we are going to create an object that will have first name and last name properties. Let's also have a greet property that's going to essentially be our method. So from here on out, I'm just going to refer to it as a method because that's logically what we have. So this is going to return hello and then person.firstname. So it's a very simple object, but it has a problem. And let's create a couple of objects so that we can see what that problem is. So the first one is going to be called John Doe. We're going to pass, of course, John as the first name and Doe as the last name. But then let's create another object that has a completely different name so that we have two different values for first name and last name. This one will be Jane Smith. So we end up with two objects that have different values for first name and last name, and that's fine because that's what those properties are for. However, when it comes to the greet method, well, we end up with two separate objects that refer to two separate function objects for greet. And that's not such a good thing because a function is rather static. We write a function to perform a specific task, and we rarely ever change that function. We end up with two function objects for the greet properties, and that means we are consuming more memory. So if we write to the console, johndoe.greet is equal to janedoe.greet, we're going to see the value of false. Well, actually, we see a reference error because I typed the wrong object. So there we go. We have false. And it doesn't matter if you use the equality or the identity operators. We're going to end up with false because the greet method on John Doe is a different object than a greet method on Jane Smith. So if we create 1,000-person objects, they are going to have 1,000 different functions for the greet method. And that's not really something that we want, especially if we are writing an application that's going to be running within a mobile environment. Now, for desktop computers and laptops, system resources aren't that big of a deal. We have a ton of processing power as well as a ton of memory. And those are the two things that we should be concerned with because in order to create these function objects, we are using CPU time. In order to store those function objects, we are consuming memory. But on a mobile device, our applications are running within a browser that is sharing resources with a lot of other tabs. And that browser is also sharing resources with a lot of other apps and services running on that mobile device. And our mobile devices just have a limited amount of CPU and memory. So if there's anything that we can do to ease our usage of system resources, then that's something that we should consider. And we can approach this in a couple of different ways. But one thing to remember is that JavaScript is a prototypal language. And more often than not, if you are not embracing the prototype, you are writing inefficient code. We could rewrite this to be more efficient. The first thing we need is what is essentially going to be our prototype for our person objects. So let's go ahead and create that object. And I'm just going to call it person prototype. And in this object, we are going to define the greet method, and it is essentially going to be the same thing. So let's just cut this and paste it up here. The indentation needs to be fixed. And let's get rid of this trailing comma whenever we create this person object. We have our prototype for our person objects. And so whenever we call our person factory, the first thing we're going to do is create a person object based upon this person prototype. And we do that with object.create. And we will pass in person prototype, which is essentially going to use person prototype as the prototype for our person object. So This person object that we have just created now references this greet method that we defined on our prototype. And the only time that this greet method gets created is right here whenever we create our prototype object. So we have created our person using our prototype, but we can also define any other properties that we need to. So the first is going to be our first name. Let's go ahead and make this a read-only property. So we will say writable is false. The value is going to be our first name. And then we will essentially do the same thing for last name. So let's just copy and paste. Let's make the necessary changes, and then we will return person. Now, over on the right-hand side, whenever I save this, we're going to see that this is true. And that is exactly what we want. And these methods work as well. So if we call the greet method on John Doe and we pass in Jane Smith, we should see on the right-hand side the value of true, and then we should see hello, Jane, and we do. But in doing this, we now have another problem. Our person prototype is out here in the global scope, and that's definitely not what we want because this is going to be the basis of all of our person objects. So we want to protect this as much as possible, and we can do that with an immediately invoked function, but it's going to be a little bit different. We're going to create a variable called person factory, and we're going to set this equal to the result of calling an immediately invoked function. And then we will basically take our existing code and put that inside of our immediately invoked function, except that in this case, we want to return our other function, our factory function that does the actual creation. So we end up with something that looks like this, but we end up with the same result over on the right-hand side of the screen. Whenever this immediately invoked function executes, it creates this person prototype, and it's going to keep this in memory because this is a closure. We create it here, we reference in the function that we then return to person factory, so that this prototype object is now protected and it's used every time we call our factory function. Now, I know that this requires extra code. It also requires extra thought. But the counter argument to that is that we are programmers. We are paid to solve these types of problems. Programming isn't easy. If it was, then everybody else would be doing it as well. So when you're creating multiple objects, look for the things that could be considered a prototype. Typically, it's things that don't change. Functions, getters and setters, anything that an object would need, but is never or very rarely modified.